Hello, this is Sal. In today's video, we'll be talking about routed ports. A routed port is a physical port that acts like a port on a router. It does not have to be connected to a router. A routed port is not associated with a particular VLAN as an access port. A routed port behaves like a regular router interface, except that it does not support VLAN sub-interfaces. What is the difference between SVI and routed ports? SVI, or a switched virtual interface, is a logical interface on a switch that is associated with one VLAN. A routed port is a physical port on a switch that acts like a port on a router. It supports all routing protocol. It does not, however, support VLAN subinterfaces, and it's also not associated with a single VLAN. Now, what's the purpose of the no switch port command? This would have to be commands provided from an interface on a layer 3 capable switch. The no switch port command puts the interface in layer 3 mode known as routed port and makes it operate more like a router interface rather than a switch port. The IP address command assigns an IP address and network mask to the interface. Here, when you look at this network diagram or the topology diagram, you will think that I'm gonna configure a sub-interface. No, I'm just gonna configure the port of gigabit Ethernet 1/0/1 as a routed port. Now on the router, enable configure terminal interface gig 00 IP address of 172.16.2.1 with a subnet mask of /24 255.255.255.0 and no shut to open the port. Now the port is open, as you noticed, turned from red to green and still orange here on the multilayer switch. Here enable configure terminal. First I want to run this command, or let me double check, show IP route. We still need to configure IP routing on the multilayer switch, so it's simply by typing IP routing like that. Now, as we said, what's the purpose of the no switch port command? Now it's just to turn it from a switch port to a routed port. And now, because we are by default, all the ports on a switch, either layer 3 switch or layer 2 switch, is a switch port, either a trunk port, switch port, trunk, or access port, or a voice switch port. Now we want to turn it from a switch port to a routed port by simply, now we are in the interface of gig 1/0/1. Now if we try to type the IP address of 172.16.2.2 with a subnet mask of 24, it will say that input detected at the marker, because if I try to type again IP and then a question mark, it does not give me the option to put the word address in order to configure the IP address. So what we need to do is just simply type no switch port, and now the interface changed state to down and then immediately to up. Now if I try to type IP address, it allows me to, and then the IP address of 172.16.2.2 with a /24 subnet mask. And I don't have to type no shut, but I'll just do it a force of habit, not some, even if it's a logical interface, but still in some cases, based on experience, that it's still not open, type no shut or open the port. Anyway, now we have two VLANs, VLAN 10 and VLAN 20. I want to configure both these VLANs on the switch. Let's type VLAN 10 and VLAN 20, and now I want to give them a SVI IP addresses for the VLANs. Now enter VLAN 10. Now the state changed to up. IP address, as you can see here on the side, 172.16.10.1, 172.16.10.1 with /24 subnet mask, and no shut. Exit. Now for VLAN 20, and the IP address of 172.16.20.1 with a /24 subnet mask, and again no shut. Now, as for this port here of gigabit Ethernet 1/0/2, this will be this PC here associated with VLAN 10. So as access port interface gig 102 switch port mode access, switch port access VLAN 10, exit, and the other interface of gig 1/0/3 switch port mode access, switch port access VLAN 20, exit. So let's see if the color here is still light orange. Wait for it till turn to green and run some pings around. Here it is green on this side on switch A. Let's see if it can ping its own default gateway of 172.16.10.1. Yes, it can. Can it ping the routed port of gigabit 1/0/1 of 172.16.2.2? And yes, it can. Now let's see if it can ping PCB of 20.2. Yes, it can. But can it ping the router? Ping the router 172.16.2.1, and it will not be able to. So what we need to do here in order to have a function network that PCs and different VLANs can ping the SPIs or the IP addresses of the VLANs or the router, we need to configure either a static route or a dynamic route. In this case, I will configure a dynamic route of either EIGRP or OSPF. I will go with OSPF, and the process ID of 1 on the router, the network of 172.16.2.0, inverse subnet mask of this, and on area 0. So on the switch, I'll do the same with the 3 networks. Configure terminal, router OSPF process ID 1, the network of 172.16.2.0, the network between the multi-layer switch and the router of the inverse subnet mask of this, also in area 0, the other network of VLAN 10 172.16.10.0 with the inverse subnet mask also in area 0, and 172.16.20.0 in area 0. Exit here. Let's wait until it establish a neighbor relationship. I'll go to the router, and now it did, loading to full, and the loading is done between the router and the switch. And the same here, we can see it notified us. So now can PCB ping the switch, ping the router 172.16.2.1? Yes, it can. And can it ping PCA of 172.16.10.2? Yes, it can. Now I will configure, between the let me run this command here, show command, show IP OSPF neighbor, and showing us a neighbor relationship here with the router, show IP route, and showing us the 3 networks connected to the multi-layer switch. Now I will configure a layer 3 ether channel between or on this network. So now we have these 2 ports, the lengths of gig 1010 and 11. I need to configure them first as trunk ports. Take the thing from the beginning, interface range of gig 1010 and 11, switch port trunk encapsulation.1q, switch port mode trunk. And I'll do the same on the multi-layer switch 2. First here, enable, configure terminal, or before that, let me run this command, show IP route. I need to configure it, configure terminal, IP routing. Now, interface range, gig 1010 and 11, switch port trunk encapsulation.1q, switch port mode trunk. And the state of the 2 interfaces now change from they went down and then change to up. Now I'm still on the multi-layer switch 2, and in the range configuration mode I will type channel group 1. The mode I will choose here active. And I will do the same on the multi-layer switch 1. We're still on the range configuration of the 2 ports. Channel group 1, mode also active. Went state to up, end. Let me run this command, show run. Here, let's take it from the top. Here we have the interface, the port channel 1, switch port to trunk, and here also for port from loading to full, loading done. And now, as you can see, now for run the command again, show run for the port 10 and 11, encapsulation.1q and switch port. And in order to turn the layer 3 ether channel, we need now both ports. We have them as port channel 1 as an interface. Let me run this command, show IP interface brief, show IP route, and show IP OSPF neighbor. Now I will configure both ports into interface, on the multi-layer switch 1, configure terminal, interface port channel 1. Now in order to make it a routed port, we need to turn no switch port port. It went down and then back to up. This is, we are configuring this on the multi-layer switch 1. Now give it an IP address of 172.16.5.2 with a subnet mask of /24, and I will do the same on the switch 2, multi-layer switch 2 here. Interface port channel 1, no switch port. It went down and then up, and now I'll configure the IP address of 172.16.5.3 with a subnet mask of 255.255.255.0. Exit. Show IP route, and showing that it is connected to the network of 172.16.5.0 through the port channel, and the same on exit here, show IP route, and also it's connected to this, directly connected to the network of 172.16.5.0 through the port channel 1. Now also if I type show ether channel summary, it's showing us here that the R is layer 3 and U is in use, and here port channel 1 RU, and through the gigabit Ethernet 1010 and 1011 show ether channel, and it's telling us the group state is layer 3, and we have the channel group listening group 1 layer 3, ports 2, maximum port it can handle up to 16. Show ether channel port channel, and as you can see here it's active and active. Let's see if from if we can ping from the multi-layer switch 2 to the router 172.16.2.1. Now we can't. Why we can't ping? Why? Because we did not include the multi-layer switch 2 with the routing protocol, with the OSPF routing protocol. But here if we type the command show IP route, it is showing here but not showing on the MSL multi-layer switch 2. Show IP route, it is not, the other networks are not showing here. So what I'm gonna be doing here, configure terminal router OSPF 1, a network of 172.16.5.0 area 0, and ping 172.16.2.1, still not, so we need to configure it also on the router. Exit router OSPF 1 at the network of 172.16.5.0, network of 172.16.5.0 with the inverse subnet mask of this in area 0. Network, sorry about that, network, exit, ping 172.16.5.3, need to include it also here on configure terminal router OSPF 1, network of 172.16.5.0 area 0, and run the ping. It will take maybe a few seconds to establish a neighbor relationship. Here it is telling us we have an adjacency, process ID 1. Let's run the ping again, and here we go. And from the router to the and from the multilayer switch 2, let's see if we can ping PCB 172.16.20.3. Did I type it right? Yeah. 20.2, sorry. Yes, we can. My bad. And 110.2, the PCA. Yes, we can. So this is it for today. I configured a routed port on a multi-layer switch and a layer 3 ether channel on this topology diagram. I hope you learned something or two from this video. Please, if you like it, subscribe to my channel and give me a thumb up and hit like. And if you have any comments, any questions, please just write me. Thank you for watching, and I'll see you in the next video. Have a nice day.